What if I say you that you can measure the length of any object using just time? Yes, time. Hello everyone, this is Aditya and today we are going to discuss the measurement of length using time. So let's start with the video, but for that please do like, share, subscribe my channel and be supposed to do. Now let's start. Suppose you have this rope and I say you to calculate its length but you are not having any ruler or any scale, then how can you measure it? But I have given you a ball and a stopwatch, so what you can do? Well, there's a very simple method which you can use, which I'm going to tell you all. So what we're going to do is that we will take this rope and divide it into 8 equal parts, not by cutting it but like this, so that it becomes compact and it is easy to calculate its length, because if we calculate the length of one part we can just multiply it by 8 and we'll get the answer, right? So yeah, we are going to do that only. So what we'll do is that we will tie one part of the rope to this ball and the second part we will use it to hang like this, and the remaining 6 parts we'll use it to as the support on any system on which we are hanging it, right? But what we will do of this? Well, just a minute. So basically this will become something like this, correct? Right? So it is acting like a simple pendulum, right? Okay. So you have a stopwatch. So what you can do is that this is L, right? Correct. So you will just oscillate it, right? And you will calculate its time period, right? And if you got the time period of this simple pendulum, we know that time period is 2 pi root L by G, correct? So we will use this expression and from this we will calculate the length of this rope, right? Okay, so let's start with the experiment and let me show you all the readings and then we will calculate it. So let's move to the experimental part. So as you all know that I divided this rope into 8 equal parts. So what I've done is that I've used one part to tie this rope, the second part I've used as the length of this simple pendulum, and the remaining 6 part I've used to hang this rope. So basically this is the whole system and it is acting like a simple pendulum. So what we are going to do is that we will calculate the time period of this simple pendulum and from that we will calculate the length of one part of this rope and then we'll multiply it by 8 to get the approximate length of this rope. And of course it is not an idle case, there is a resistance also, and like I have tied it like this, of course there will be more resistance on this and some other things, right? But still we will get an approximate answer for this. So let's calculate this. So for this purpose I'll be using a stopwatch, and of course I don't have a physical stopwatch, so I will be using the mobile stopwatch, only a virtual stopwatch for this purpose. So first of all we will take one reading and then we take the second reading, then we will take the third reading. So I am thinking that we should take 5 readings at least. So let's do the first reading. So this is the simple pendulum, this is the bob. So I'll bring it like this, and once it's over here, now I will leave it. So let's start. So it came 1.71 in this case. Now let's take the second reading. Now let's take the second reading, and in this I will move it a bit back like this, and now I will start. This time also it came around 1.71, right? Okay. Now let's take it more back and let's see what happens. Like this. Now I'm going to leave this. So this time it came to be 1.86. Yeah. Now let's take the fourth reading. So in that I will bring it over here, this much, and then I'll leave it. This time it came to be 1.79, right? Okay. Let's take one last reading and then we will move to the calculations. So this time we will go a bit back and now we will leave it. This time also it came to be 1.79, right? So we have 5 readings. So now we will see the calculation and let's calculate the approximate length of the system. So let's start. So this was our reading. So T1 came out to be 1.71 and T2 came out to be 1.71 again, and T3 came out to 1.86 second, and T4 came out to be 1.79 second, and T5 also came to be 1.79 second. So I have taken the sum of all these time and then I took the average, so I got this value, that the average time is 1.772 second, or we can just say 1.77 second, right? Okay, so now we will use the formula. The time period of a simple pendulum is 2 pi root L by G, right? And now what we're going to do is that we will calculate length from this, right? So let's calculate that. So we have T square by 4 pi square into G is equal to the length, correct? And now let's substitute the value as 1.77 second over here, and let's see what we are getting the length of one part. So on substituting the value as 1.77 second and the value of G as 9.81 meter per second square and pi is 3.14, we are getting that length is 0.78 meters or 78 centimeters. So this is the length of one portion. So we will have the length of rope is basically 8 times 78 centimeter, and it comes out to be 624 centimeters or 6.24 meters. But of course it is just an approximate result, because of course we all know that we calculated this length in presence of a resistance also and in practical situations, and of course it was tied like this, so it will of course create some more problems, and of course there can be some human errors also. And most important, the mass of this ball was much greater than the mass of this rod, so that is why the center of mass of the system would have lied somewhat near the center of this ball, right? So of course the value of L which we have got, L is actually length of rope plus the radius of this ball. But since there were many errors in this calculation, of course there are many things which we did not consider, like air resistance and other things, so that is why we can neglect this, and we can say approximately that lump sum this is the approximate length of this rope, right? Of course we are doing calculations at home, we are doing the experiment at home, and we are doing it in a practical situation, not in an ideal situation. So of course there is scope of error, of course, right? But the sole motive of this experiment was to tell you all that how we can apply physics in our daily life also. Like for example, if I say that you can measure time, you have a stopwatch, you have a mass, you have a rope, and you have a supporting system, then how can you measure length of that rope? Well, then you all think that how can we measure it? So this is how you can calculate. So basically you can measure length from time, and that's really mind blowing, because we all think that how can we measure length from time and like that. Of course you can calculate, but of course you should know some physics also, some physics of pendulum and some other concepts. This was just one example, there can be infinite examples which I can give, but like this is the basic method which you can use. Of course, I know I will get comments like, we can use that skill simply. No, this video is not about using skill. It was to tell you the meaning of physics, how interesting it can become if you try to apply in your daily life also. So I hope so that you enjoyed this video. If you did, then please do like, share, subscribe my channel, and please support this video. Bye bye. Take care.